So good morning. We're going to do a little bit on the four-cycle theory in small engines today to get started. And regardless of how you use this information after you leave this class, chances are you are going to have some contact with a small engine. They're just that common. So definitely over 100 million of them now that are used in the United States. You probably have a lawnmower at home or a chainsaw, or maybe even a weed whacker. They do make some that are four cycle. Most of those are two. Same thing with the chainsaw. 6 million engines purchased each year. So you might have a snow blower, which is the motor that we're going to be working on. Air compressor, chainsaw, things of that nature. They put a motor on just about everything these days as long as it's appropriate. So, all right, so your small engine sizes are going to range for horsepower from about a half horsepower up to 15. And there's a number of companies that manufacture them, but one of the biggest ones is Briggs & Stratton. Briggs & Stratton is the company that donated our motors for your lab. And Tecumseh is a company that is also large. They do a lot of different kinds of motors. Kawasaki, Kohler and Tecumseh are pretty common over where I grew up in southeast Wisconsin. Kohler Company is in my backyard. In fact, it's a neighboring city. So, and then you got Lawn Boy. So a lot of manufacturing there. All right, so there are advantages and disadvantages, and one of the advantages and reasons why they're so prevalent is because they're pretty inexpensive to get, especially something like a push mower. You know, you have a couple $100 and you can invest in a tool that'll help you. And they're relatively inexpensive to operate. That push mower that you spent a few $100s on doesn't take much fuel to operate and to cut your lawn. Certainly cheaper than having somebody come do it professionally. Typically, they're portable, depending on what they're attached to. They're typically compact and light enough that you can carry them. So most of the time, they're going to be air-cooled and somewhat of a self-contained system. And typically easy to service. So disadvantages to small engines is that they can be hard to start. Your pull system that's on a small engine can have a lot of issues mechanically, and then not to mention that you get a little carbon and stuff in your carburetor, and then all of a sudden you've got a engine that needs to be serviced and is very difficult for you to get rolling. So they tend to not have a very long productive life. In other words, you can beat on them and they're going to wear out pretty fast. So, and engines for the most part are pretty low in efficiency anyway, but small engines are definitely on the low end of that aspect. So. All right, so an engine essentially is going to convert your gasoline or your fossil fuel energy into mechanical energy. So that chemical energy is a mix of air and fuel. You have to have both in order for your small engine to operate. So basically we are atomizing the fuel by adding air to it. You might have heard of an atomizer, especially if grandma had one or something of that nature. That's simply just a pump that pushes air into some form of liquid. Okay. So then it ignites that fuel-air mixture. So now you have heat energy and expands the pressure inside the combustion chamber. And that immense amount of pressure forces the piston down. So now you are changing mechanical energy to reciprocating energy. And so then that transfers to the crankshaft and into your whatever it is that you're working on. If you've got an axle that's connected to it, it'll turn that, rotate that. Every step of the way, you're going to lose a little bit of energy, and remember that you are not creating energy anywhere in this system because you cannot create it. It can only be transferred. So if you think of these different steps, you're losing a little bit of energy every time you go through those steps. So this is one of the reasons why small engines are just not very efficient. So being inefficient there, about 25 to 40%, that mechanical energy coming from the chemical energy. All right, so where's that going? Exhaust and heat. And if you are operating a car or a pickup truck, you're losing about 40% to cooling within your radiator system, or air cooled system. You're gonna lose it to that too. And then engine friction. So engine oil, a good quality engine oil is pretty important. So basically that's how you end up with your usable power. So there are 6 events. We're going to go over them. You got intake, compression, ignition, combustion, power, exhaust. Okay. Now, that's 6 events that take place. There are 4 cycles in a four cycle engine, or 4 strokes in a 4-stroke engine. We'll go over that here in a bit. We're going to watch real quick a very short video on these 4.
We're going to go over the 4 strokes of a 4-stroke engine, which are intake, compression, power, and exhaust. And we'll go over each one of the strokes in detail from the perspective of piston.
You got your 3 cylinders, so 6-cylinder car. You got 3 cylinders on each side. Your 3 pistons inside the cylinder. The cylinder is this actual cavity. Inside of it, you got the piston.
Piston goes up or down depending on what stroke you're in. Stroke number 1, intake, down. Piston's going down, the air is coming in, the intake valve is open, letting that air fuel into the combustion chamber. And then at the bottom of that stroke, you are completing your intake stroke, and you're now ready for your next stroke. Both valves are now closed, and the piston's on its way up. Piston's on its way up. It's compressing the air, raising the temperature, raising the energy potential of the air in the chamber for the next stroke. So at the top of this stroke, when the piston's all the way up, you're now ready for the next phase, which is power. Down! Piston's going down. And why is it going down? Because you have just introduced spark. This creates an ignition. Boom! You have an explosion in the combustion chamber, which slams the piston down. And at the bottom of that stroke, you have completed your power stroke. Both valves are still closed in the power stroke, just like they were in the compression stroke. Now you've got all of this used or expended air, which you just exploded or combusted or whatever. So you need to get rid of it. So now it's time for the final stroke. Time to go back up. Open the exhaust valve and raise that piston and push that air out of the exhaust. If the pressure was too low, you might just have some flames coming out of your exhaust. And us Lamborghini fans, you like that. But it's very important to have a right balance in terms of the right amount of compression from your power stroke, from your compression stroke, right? Everything should be perfectly balanced. Right amount of fuel, right amount of air, right amount of compression, so you have the most efficient possible engine. There you have it. The 4 strokes of a 4-stroke engine. Intake, compression, power, and exhaust. Simple. I'm going to show you how it's like.
No, you're not. That guy is quite a bit more punchy than I am this morning, so Fritz is tired. All right, come on, computer, catch up. All right, so he talked about the 4 different strokes. All right, compression is also called the power. I shouldn't say that. Hold on, back up. We'll just start with the intake stroke. Slow down, Fritz, so you don't have to go home today. So the intake stroke is basically your intake valve is opening here. So right here is you got 2 valves up at the top. This is an overhead valve system because the valves are on top of the piston and the chamber there. So that's the style that we're going to work with here. And so you've got 2 different valves, and you notice that this one is open. So your fuel air mixture is coming in through here and going into your chamber. All right. So, and it's doing that because it's creating a vacuum. And if you go back to the previous thing, so it's creating a vacuum in the space above the piston here. So this purplish blob here is your fuel air mixture, and it is drawing it in as the piston comes down. Okay, so that's your intake stroke. I like how they put oil down here in the crankcase that's way down in the bottom. Funny. All right, not going to do much good there. So then you got a compression stroke, and so now the valves are closed. Okay, so we got this gas that's in here after it came in through the intake valve, and now the piston's coming back up, and it is compressing this. All right, so it is putting an awful lot of pressure, and this is the point where older motors become pretty inefficient because there's only so much pressure you can give after have running for how many hundreds of thousands of miles, especially in your vehicles. So you need that compression in order to have power. All right, and up here in here somewhere where they're going to show it in the picture is going to be a spark plug. All right. And so that's called your power stroke. And you need to have that spark plug. So let's kind of imagine a spark plug up here somewhere. And this is a very crude drawing. You've obviously figured that out. And it will ignite that compressed fuel mixture. Okay. And it will shove it back down. So now the piston is coming back down. And it's coming back down because of the force of your ignited fuel. Okay. All right, your fuel is burning rapidly at this point, creating a ton of heat and pressure. All right, and it's important to note that in this compressed state, you're not exploding, although that's kind of what we might think is going on. You are igniting that. It's kind of like when, if you've ever played with gasoline, not saying that Fritz has, like back in the 40 acres there where you're burning garbage and you're trying to get something that's difficult to burn. If you have liquid gasoline, you light that on fire, it's going to not be too exciting. It is the atomized fuel right above the liquid that creates your explosion. But when it's under pressure, it's a whole nother system, basically. So if you have an engine knocking issue, you have an issue with some of that fuel actually exploding, so within the system. So. All right, now you got the exhaust stroke. Exhaust valve opens, and oops, there's no picture for that. Are you kidding me? All right, so we'll come back to this picture. So I don't know where the picture went for that. So your exhaust valve is going to open, which is on your other side here, and your piston, as it comes back up from the power stroke, is going to shove all that exhaust out. It is important to note that in a 4-cycle motor that you're going to have a certain amount of incomplete combustion, which means that some of this mixture is not going to get burned efficiently. And so that's where your air pollutants come from, because they come out the exhaust and go into the atmosphere, and so on and so forth. Air pollution is attributed in some form to our engines that we run on a daily and incomplete combustion. All right, so basically we're not going to do a whole lot of math here, but we have an average speed of 3,600 revolutions per minute, okay, which breaks down into 60 revolutions per second. So that's pretty fast. All right, your piston is moving, accelerating, slowing, stopping, changing directions 120 times per second. All right, so just to give you an idea of what kind of power you have in a small, tiny little engine. So, all right, go ahead and do your extension activity, and there's another short video for you to watch that I am not narrating. So happy times for you. So. So you guys have a good day today.